You always got things in the way. I gotta tell the chat room we are starting.
Oh, that's adorable.
We are here. What is
the turtle?
Tortoise.
Tortoise. Sorry, thank you.
Tortoise, turtle.
I mean, you're not entirely wrong. All tortoises are turtles. So just slightly more specific.
Yeah.
I really need to figure out a better setup for my camera. It's right in front of everything. I'm like looking around, leaning to the side. We are live. So let's start this show in 3, 2. This is TWIS. This Week in Science, episode number 708, recorded on Wednesday, February 13th, 2019. Do you love science? Hey everyone, I am Dr. Kiki, and tonight on This Week in Science, we are going to fill your heads with ancient light, loser love, and a walk on the beach. But first...
Disclaimer, disclaimer, disclaimer. Adventure. According to Wikipedia, an adventure is an exciting experience that is typically a bold, sometimes risky undertaking. Adventures may be activities with some potential for physical danger, such as traveling, exploring, skydiving, mountain climbing, scuba diving, river rafting, or participating in extreme sports. And while risking life and limb may seem adventurous to some, there is another form of adventure that requires less limblessness. Science. Every question posed, every experiment run, every data set examined is an adventure into the unknown, an adventure into unexplored territory, an intellectual skydive into a world we often learn we just barely know. And while getting to know the world we live on, there are, understatement, many more places beyond our world that we have yet to explore. So if adventure is something you love, pack your bags, get ready to take on anything that comes your way here on This Week in Science. Coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki and Blair.
And a good science to you too, Justin, Blair, and everyone out there. Welcome to another episode of This Week in Science. We are back with all sorts of science. Great stories. It's almost Valentine's Day. This is our show about love, right? And so it's an ode to science. Do you love it?
Yeah.
Come on, crickets. What's up?
Absolutely.
Crickets. Yeah, I love crickets.
We love all things sciencey and hope that you will find a love for them on tonight's show. I have stories about the end of the world, lost loves on Mars, and an interview to discuss a few giant physics experiments and the sting of defeat in science. What do you have for us, Justin?
Oh, what would Valentine's Day be for Justin without a meandering Neanderthal and a even earlier potential multicellular life discovery on Earth?
Ooh.
And when I say that's a big understatement, even earlier, much earlier.
Taking it way back.
Yes.
Love started a long time ago. Blair, Animal Corner, what's in it?
Well, you said science is for lovers. It turns out love is for losers. Some science on that. I'm not cynical. There's real science there. And I have birth control. It's all in your head.
Okay. Don't take that advice.
Yeah, let's just keep going till your segment.
I'm gonna have to learn more about that.
All right.
Sure.
Okay. As we jump into the show, everyone, I would love to remind you that if you have not subscribed yet, you can do so all places that good podcasts are found. Check us out on Spotify, Pandora, Stitcher, Spreaker, Apple, Google, tune in, all the places. You can also find us on YouTube and Facebook. Search for This Week in Science, or just visit twis.org. But now it is time for our interview. I would love to introduce you to our guest tonight. Dr. Brian Keating is a professor of physics at the Center for Astrophysics and Space Sciences in the Department of Physics at the University of California, San Diego, where he leads the ACS Center for Experimental Cosmology. He's also associate director of the Arthur Clarke Center for Human Imagination. I want to go hang out there. He authored Losing the Nobel Prize, A Story of Cosmology, Ambition, and the Perils of Science's Highest Honor. In 2016, he was named director of the Simons Observatory in northern Chile, which when it's completed in 2022 is going to be the world's highest altitude and most sensitive instrument ever designed to study the origins of the universe. Welcome to the show, Dr. Keating.
It's a thrill to be on. Long-time watcher, first-time guest.
Nice.
I found that really thrilling, personally, when you were like, I've listened to you for a decade. I went, oh my goodness, this is exciting.
Go back to Leo Laporte days. Yeah, watching you guys.
Yeah.
Long time.
Well, I'm glad that our science has been a guest in your scientific life.
Absolutely.
And now let's turn the tables, and I want to hear about you. So can you give us a little insight into your journey and how you came, as it's Valentine's Day, so how you came to love and study astrophysics and cosmology?
Yeah, I fell in love pretty early on as a adolescent, a preteen, growing up outside New York City. And one night, awakened during the night by a very bright light whose origin I could not really discern. And next to it, when I peered out and recognized, removing the sleep from my eyes, it was the moon. But next to it, the moon was joined by this very bright light. And, I thought for a second, maybe it's, United Airlines flight 1632 coming in but it wasn't. It was staying stationary for almost an hour on end. And this is 1986. So this is 14 years pre-Google. So it wasn't like I could go back and, look it up and Bing it, as the kids are wont to do. But instead, I had to wait until Sunday. So it was probably Tuesday night, and I had to wait almost a whole week until the New York Times came around with its Cosmos section. And it had within it a description of the positions of the moon and the various naked eye planets and constellations that one could see from New York. And I realized that the object that must have been next to the moon when I saw it earlier in the week was the planet Jupiter. And I felt like I had made the discovery of a lifetime, that no one else had ever seen the planet Jupiter, besides me, although I realized that probably wasn't the case since they had a whole diagram about it. And then I resolved to get a telescope, to actually look through a telescope to see what I would see with a telescope. So I put in an application to the National Science Foundation. No, I applied to another three-letter organization that funds many budding scientists, the MOM Foundation.
Right.
My mother, she provided the research grant, my first research grant. I always credit her in all my papers. Nice. And because of that, I obtained a tiny little refracting telescope, which I later learned was basically exactly the size of Galileo Galilei's telescope in 1610, 400 years almost earlier than I was. Beat me to the punch, scooped me, if you might believe. And I saw the exact same things as he saw. And again, I had that same rush of discovery, of feeling like, gosh, I'm the first person who's ever seen a crater on the moon or a moon of Jupiter. And that was just so thrilling to me. I started to think about what it would be like to actually, make new discoveries of my own that were truly new. And so that really, set me on the path of wanting to be a scholar. I realized that was really my first bit of scientific research, kind of delaying.
Absolutely. You actually did discover Jupiter in this. I mean, because nobody told you, look here, right? You'll see a thing and we're going to tell you what that is. You made the observation free from all of this. So just a little bit of timing in terms of being first was off, but still, no, that's a fantastic story.
Yeah, it was, looking back on it and, having a deep connection with what would later happen in my life, where I created a type of refracting telescope, which is a telescope that uses lenses, not mirrors. Most people are familiar with giant telescopes like the Hubble or the Keck telescopes, or here in California, Mount Palomar, Mount Wilson. But in the past, much more cheaper and more effective were the spy glasses, like a pirate might sport. And
I spy a planet.
that's right. And so we ended up designing and building a telescope that was a refractor, but not to see visible light, to see microwave invisible heat-like emanation from the Big Bang. And I only later in life realized that Galileo would probably be pretty proud, and he would probably understand exactly what we did, because the devices are so simple and so powerful. And that's what I love about astronomy. I mean, we're in a loving mood. It's Valentine's Eve, right? What I love most about astronomy is that it's completely a politics-free zone. I mean, pretty much. I mean, I have politics in my department, meetings, which can go on for hours and be, incredibly violent. but they say about faculty meetings, they're so intense because the stakes are so low. The constellations, the universe, it's not political. There's no Republican constellation or, Democratic moon. It's basically free of that, unlike almost every branch of science, and certainly in politics. I love that politics-free aspect of, especially in these crazy political things, right?
And you have, and in these experiments that you're working on now, there is massive international collaboration. I mean, you are working with scientists from around the world to make discoveries that will affect human understanding.
That's really the best part of it. I mean, I have students now from Thailand. I've had students from Uganda to, literally at any, point during the year, I'll have students or colleagues on every continent on Earth. And because of the massive need nowadays, when we run as you mentioned, the Simons Observatory, which will be one of the world's highest altitude observatories when it's complete, we have 257 people working on it. Currently on 6 continents, because Antarctica is basically shut down for most scientists now. It's just amazing. These people range from 18 to 80, and I get to learn so much from them every day. It's just a phenomenal way to spend a lifetime.
And that is something that everyone in the world kind of has in common, is the view from here, right?
Yeah. I mean, we're born with 2 refracting telescopes on our heads. Justin, you got an extra pair of lenses up there. But, we have these 2 telescopes, our eyeballs. And instead of coupling them to our retinas, we couple these microwave lenses to microwave detectors, which, oh, by the way, they operate near absolute zero, almost 0 degrees above zero, absolute zero. So this is just, mind-bending technology that we get to use. And by the way, we get to study the possibility that we may not live in the only universe that exists. That's the ultimate goal of studying. Yeah.
Okay, so we're gonna have to roll through some things to get to that.
Okay.
I know. Okay, so you're talking about these microwave detectors, and from graduate school forward, you were involved in something called the BICEP experiment, and this is part of the telescope, this microwave telescope that you helped to create for the BICEP 2 detector. Yes.
Yeah.
And that was in South America, and not South in Antarctica.
Yeah, the South Pole.
The South Pole. So you talk about it needing to be cold. You talk about it. Was it located in the South Pole because it's cold there, or because it's
partially
on the opposite side of the Earth from where these waves?
Yeah, I had some creditors chasing me, so I want to get on the opposite side. No, I mean, I would love to stay. I'd love, my wife would love it if I stayed in California. But no, we went to the South Pole because it's essentially one of the driest deserts on Earth. The temperature can be so cold that snow cannot really precipitate out. It really just crystallizes and falls out of the atmosphere, more or less. And so now the reason that we go there is just the same reason that you wouldn't build an optical telescope in the middle of Las Vegas anymore. There are telescopes near big cities, but those are historical. Nowadays, new telescopes are built in remote parts of Chile or Hawaii, the Canary Islands, etc. And why is that? Because what they're looking for is optical light, visible light which occupies the narrow sliver of what's called the electromagnetic spectrum. What we're looking for is a thermal emanation from the fireball that was the result of the formation of the earliest elements in the universe. And that heat signature has cooled off from, a toasty near infinite temperature to a more balmy 3 degrees above absolute zero. So just a whisker above 270 degrees below 0 Celsius. And this temperature comes to us in all directions. It's called the cosmic microwave background radiation, discovered in 1965 by Penzias and Wilson in New Jersey. I'm a New Yorker, so I like to say that was the best thing that ever came out of New Jersey, but don't hold me to that. The discovery resulted in them winning a Nobel Prize 13 years later, and it's been called one of the most important discoveries of all time in any branch of science. That's because it really indicated for the first time evidence, physical evidence in the form of tangible, testable data that proved in some sense, or motivated in some sense, that the universe began in this hot, dense state, made famous years later on the television show of the same name.
And I love the fact that they go on to win the Nobel Prize, but were cleaning pigeon poop off of their detectors because they thought they were maybe getting interfered with. But this is how you get a Nobel Prize. You also have to at some point clear out pigeon poo.
Yeah, that's right.
Confirm
when Penzias and Wilson are trying, as all good scientists would, to suspect themselves of making an error or blunder, and when they pointed the telescope at New York City, for example, to see if that was the source of this hissing glow of microwaves coming in all directions, they could not eliminate it even by looking away from New York City. So I like to say, that they then tried to find if other dirtbags besides New Yorkers were causing the signal, and they looked at these pigeons, and they actually had to end up killing the pigeons. And so I would have liked to have been on the NSF budget team, that approved the shotgun, for these. What exactly are they doing in New Jersey?
So the cosmic microwave background radiation, you're looking at it, but what is it telling you? What information are you trying to glean from it? And how on earth could that tell us whether or not we're in our own?
Yeah.
Universe,
So,
right?
those CSI, programs that show these investigators and they come to a crime scene, there's a dead body there. What they don't usually show you is that what they do first, and medical examiners, they bring a thermometer and they measure the temperature of the deceased, as they call it. And when they measure the temperature of the deceased, they are really measuring how much time has elapsed since that deceased body was alive. And that living body is at 90.
Processes have ceased. Yes.
Yes. The human body 98.6 degrees normally, and by comparing that temperature to the ambient temperature in the room, and knowing that the human body is mostly water with other substances who have a well-defined cooling curve and what's called a heat capacity, how much they cool off and can store energy versus time, they can calculate very accurately when the last time that body was producing energy until later comes to equilibrium in the room. So by measuring the temperature of things, you can determine how much time has elapsed since they were in a given state. In the case of the universe, by measuring the current temperature of photons that come to us in all directions, not from a star or planet or somewhere else in the universe that's identified as an object. If you look away from all objects in the universe, you get this immense amount of light that's coming to us. And these photons encode with them how much time has elapsed since they were produced. In this case, they were produced when hydrogen was formed. And that took place about 500,000 years after the Big Bang. And so 500,000 years after the Big Bang, the universe stopped being hot enough to have hydrogen not be formed. And so hydrogen got formed. So it's exactly like measuring the temperature of a dead body in order to extrapolate how much time has elapsed. But furthermore, just as you could do some sorts of extra experiments, if let's say you didn't know the human body was composed of water, but you knew very accurately how it's been cooling off, you could learn about the composition of the human body from how its current properties are compared to snapshots in the past. So depending on how you look at it, you can learn about the composition of the universe, the past history of the universe, or maybe even make a prediction what's going to happen in the future. And that's sort of intertwined. All three of those are intertwined with what we do nowadays with telescopes like BICEP, BICEP 2, and now the Simons Observatory.
And what you're looking at, and it's going to tell you, we know that there was this inflationary period when after the Big Bang, everything inflated and got really big, and it was this really hot period, right? And then it cooled down. But since then, we've had expansion. And we can measure all of this expansion that's going on, but it's the inflation that's this vague kind of, okay, we've got these photons and the photons were formed. What happened right before then?
Right. Exactly. So
Get information out of it.
yeah, so exactly. So what if you think back in history, what happened for millennia is that people thought the universe was infinite. Even Einstein basically thought the universe was static and eternal, and that was as late as 100 years ago this year, basically. And it wasn't until there was evidence from Hubble and others that showed that galaxies are in motion, and so you can't assume, and they're all receding from us, by the way, and that led to an inescapable conclusion that the universe in the future will be bigger, more diffuse, more dilute, but also concomitantly, that in the past it was much more compact and small and dense. That hot, dense state came to be known as the Big Bang, which really slaughtered the competing model which had prevailed for millennia, which was the steady state universe, that the universe had existed for all time. And everybody believed that and thought it was basically ludicrous to assume the universe sprang into existence with the Big Bang. Nowadays, we take it for granted. But you're right. Then what scientists do, and it's frustrating to non-scientists, they always say, like, all right, you just told me about some big discovery. Now you're telling me there's a problem with that big discovery and there's something we don't understand about it. Then you make some patch and Band-Aid and then that has a problem. But that's really the fun of being a scientist. You get to like prove people wrong all the time. And no one's above being proven wrong. That's the best part about it. There's no authority so astute that he or she cannot be taken down and dethroned. So what happens now is that there's a controversy every bit as heated as the debate between the pro-Big Bang people and the pro-steady state people 50 or 100 years ago. And it's really, you made a statement, Kiki, that we know that the universe inflated, but actually we don't know the universe experienced what's called cosmic inflation. And it's as if we are sort of back in this period where we don't know if there was a Big Bang or whether the universe, not that it was static. We know the universe could not have been static, but there are just as many, very eminent theoretical and experimental physicists who believe the universe might be cyclic. In other words, there might be big bangs and big crunches and collapses and expansions that themselves last perhaps for an infinite amount of time. And we're just the latest in one cosmic epicycle. This is taken very seriously, and it's actually the main thrust. If I have to characterize what I do, it's to try to parse and determine, how did the universe really begin? What happened 15 minutes before the Big Bang? Was there another universe that collapsed and then exploded into our inflating universe? Or was our universe the first of a kind and had never existed and never will exist again? Those are the really roiling, boiling controversies that cosmologists find themselves in, to the extent that you can, say how controversial what we do is.
I think that there is pretty decent argument though, that every time we've ever thought that something is the unique, the one, the only, it's been proven wrong. This is the only planet. No, there's another solar system. Oh, there's two solar systems. Well, actually, there's a lot more than two solar systems. Oh, there's two galaxies now. Yes, we've discovered that there's two galaxies. Well, actually, there's billions of galaxies. So it would, for the progression from where we came from and just our understanding, it would sort of be now intuitive to assume that there are other universes out there.
Exactly. And that's this, Justin, what you're getting at is this relatively new kid on the block, which is called the multiverse, or the theory of the multiverse, which posits exactly as you say, kind of extending Copernicus from saying how utterly insignificant and ordinary our solar system is, now extending that to knowing that there's 100 billion stars in our galaxy. There's perhaps 100 billion galaxies in our observable universe, and each one of those could have 100 billion stars, and each one of those could have 1,000 planets or planetesimals. And so if you keep extrapolating to this, you get, many, many billions upon millions of star systems, planetary systems rather, that could possibly exist. And so Then the next syllogism step is to say, well, why not call the universe just one island in what's called the multiverse? And things got even more interesting when about a decade or 2 decades ago, people started to realize that it's called string theory has a deep connection to this notion that there could be not only different universes, but different laws in different universes. So it could be that, in fact, every one of the different possible universes could have different laws of nature. And in that case, it could explain why we find ourselves living in a universe that's compatible with us finding ourselves in a universe which is compatible. So it's called the anthropic principle.
Right.
And this is a great, deep, very abiding mystery that is, to me, the most exciting thing that one could potentially study, because it unites the very smallest things that may exist and most ubiquitous things that might exist with the very largest things which may be unique or may not be.
And so looking around, I mean, we barely barely scratched the surface in our own universe, right? So how do you start looking into these hypotheses, these ideas about multiverses and the Big Bang versus the Big Crunch versus this repeatedly cyclically how do you look into that?
Yeah. So what I think, was sort of a niche that I wanted to fill is that, most of the books that are written about cosmology, about physics at its smallest levels, they're written by, theoretical astrophysicists, theoretical cosmologists, Lisa Randall, Brian Greene, Stephen Hawking, late great Stephen Hawking, and many others. And there are very, kind of few treatments from the standpoint of people that do what I do, which is to build instrumentation to really go after and try to prove those people wrong. You can write a book about, distant time warps and wormholes and things like that, and you may never be proven wrong, in your lifetime or maybe in 50 lifetimes. But there's only so many times you can, make an experimental mistake or do something completely wrong and wrong-headed and still be able to, be a professional, gainfully employed astronomer. So in my case, and I always find it interesting, it's like you have all these incredible things. Like Lisa Randall has a book, Warp Passages about extra dimensions. And I'm like, and she's a friend of mine. I love her writing. And I'm like, Lisa, you can't really put a wormhole on your cover of your jacket of your book, but you can put dust on the cover of your jacket. And that's what I did, with my book. There's a dust jacket, and that's because dust is really this ubiquitous substance. And what we do in our work nowadays is we're not really day to day looking and philosophizing about, extra dimensions and brains and multiverses. We're really trying to build the most sensitive instrumentation to prove those hypotheses wrong. So there's a misconception that what we do is we go out there and try and prove that inflation happened and prove that this theory or that theory is correct. In reality, most of what we're doing is trying to what's called falsify or prove wrong any number of competing hypotheses until what you're left with is really the only, in the Sherlock Holmes sense, the only inescapable conclusion left. And that one has a high probability of confidence in being correct. So
Isn't there though? I mean, part of it is that theorists have of course, the successful ones, right? The ones this is ignoring all of the misses, okay? but a lot of the hits have come long before we had the ability or technology to attempt to falsify them and have them maintain. So I get that I'm missing. I'm we don't talk a lot about those misses, but is there territory for new discovery within experimentation that has not been conceived of, and is there an example of that?
Yeah, I think, in the book, I really distinguish between what's called a serendipitous discovery, a discovery that you don't expect, versus one like the Large Hadron Collider. When it discovered the Higgs boson, there was a very good reason to expect the Higgs boson would exist. Not only that it would exist, but it would have certain properties, mass, cross-section, all these other things. And then an instrument was built to discover it. On the other hand, as we were discussing earlier, Penzias and Wilson didn't build a telescope to catch the heat left over from the Big Bang.
Great example.
And so it's a very different type of discovery. And I claim those latter serendipitous discoveries are more pure because You're not trying to confirm a hypothesis. There's always a danger when you have a theory of what's called confirmation bias. And people like to think that we scientists are immune from prejudice and fallacies, and all it takes is, coming to a faculty meeting and as I said before, seeing that's nowhere near the case for real scientists, and that we have the exact same prejudices, biases, and predispositions as any other human being has, because we're human beings. And
that's always the thing that terrifies me of an opening statement of a research paper is, we went out to look for this and we found it. That's like there's always a little bit of a like, well, you started looking for that. So yeah, did some sort of confirmation bias leak into what you selected as your result?
Yeah. So I really feel like there's, kind of big rewards that can come about from, really what's called really basic, pure research, not applied, where you're, building a bigger accelerator and of a known character. And right now in this week in science, people are debating the merits of building, 20 billion euro experiment to smash atoms at higher and higher energies. In that case, there's really not a clear goal for such an instrument. There's no natural, a target or threshold to cross. It's kind of bigger is better. And people have argued that, why that's good or why that's bad. But I think, pure discovery, it is pretty rare. And it's a magical thing to be a part of. But I don't want to denigrate in any way the kind of science that I'm doing, which is really clearly, specifically going out, in our case, either to disprove a theory, in this case, inflation, and show that the universe was maybe preceded by infinite cycles of kind of maybe perhaps infinite cycles or in the past. But also it could be that we, along the way, are discovering new things about the composition of the universe, what it's made of, the particles, fields, forces, and dynamics. And so what I love to do as a scientist is do something really high risk and extremely high reward, which in this case is like disproving the existence of inflation, or proving, in some sense, motivating that the universe had a cycle before it, maybe one, maybe infinite. And but I also like to do kind of pick the low-hanging fruit, which is to understand what the universe is actually made up of, what particles and fields and forces make it tick.
And that way you will always be able to publish something.
Yeah. The low-hanging fruit for the funding.
That's right.
Or
exactly.
Awesome stuff for the...
You guys got it. That's right.
There we go. So back to your book, you talk in your book about your experience with the Bicep 2 experiment, and this massive experiment with a massive finding that we reported on this show that was later found to not really be. And so I'd love to get you to explain what happened to our audience.
So if inflation took place, most theoretical cosmologists and experimental cosmologists expect that what would have come along for the ride are what are called gravitational waves. So you reported on LIGO's discovery of gravitational waves, which were produced from the in-spiral, a collision of two rapidly rotating black holes, each one about 30 times the mass of the sun, colliding about 1.4 billion light years away from the Earth. That was the LIGO discovery that ended up resulting in them winning a Nobel Prize. We can talk about that later if you like. But the fact that you should keep in mind is that when you have matter in motion and in an accelerating fashion, like these two black holes, it produces gravitational waves. So the ingredients for gravitational waves are very simple. You need a lot of matter accelerating very quickly. So where would you think you'd get the most amount of matter in the universe and the biggest acceleration that you could possibly have? It's at the very beginning, when not just 30 solar mass black holes, the entire universe's mass was exploding, accelerating, perhaps some say faster than the speed of light. And so at that time, that's what inflation is. It's the superluminal, faster than speed of light expansion of space and time itself, which is potentially so violent that the fabric of space-time is resonant and is ringing with gravitational radiation or gravitational waves. These waves of gravity, like light particles, live forever. They have no clocks, no lifetimes associated with them. They travel at the speed of light, in fact. And they existed until the time of the formation of that dead body, of that CMB, the cosmic microwave background, 400,000 years after the Big Bang formation of our current universe. So they would have messed up the matter and energy distribution when the cosmic microwave background photons started traveling towards our telescopes. So I realized after consulting many theoretical arguments in the 90s that we could build a telescope that could capture these waves of gravity, not directly by coming into our laboratory today, because they're much too faint to be detectable, but rather use the universe in an infant state back when it was about 400,000 years old. And by doing that, we'd use the universe as our gravitational wave detector. And that produced what are called curl mode or B mode patterns of microwaves. And I don't want to get too technical. I describe with illustrations, et cetera, in the book. But really what we expected to see if inflation took place are waves of gravity. Those waves of gravity, in turn, imprint a swirling, twisting, curling pattern on the microwave sky. And that's why I came up with the name BICEP, which is an acronym for Microwave Background Imager of Cosmic Extragalactic Polarization. Say that 5 times fast. And we actually made a discovery, which indicated that we saw gravitational waves. And they made this twisting, curling pattern of microwaves. And we announced it on March 17th, which is St. Patrick's Day in 2014. And that's when you guys were covering it. And it made the front page of every newspaper in the world. I mean, literally, the New York Times, the Economist, every single magazine, newspaper that you could imagine. And, one of the leaders was one of Time Magazine's, top 100 most fascinating people of the year. And by this time, I had been excised in some sense from the collaboration, unfortunately, because I had chosen to join a team which was viewed by many as a competitor. So even though I created the experiment and it was had paternity rights, they were kind of taken away. I still had visitation rights, but I didn't have paternity rights.
You can still kind of look at the data, see what was going on.
Van Gogh never got paid properly for Starry Night. Seems like it might be this similar scenario.
Yeah. I could drive by, look through the window, but we had this press conference at Harvard, and I wasn't at it, but yeah, it made millions of views on YouTube, a video produced by Stanford University, one of the home institutions of the project, and so it captivated the world because it was described on that day as perhaps the greatest discovery of all time, and assuredly worthy of not one but many Nobel Prizes by previous Nobel Prize winners and commentators and pundits in the world of science. And eventually it came to be that even I was being whispered as a potential person of interest for the Nobel Committee to consider when doling out the Nobel Prize later that year. There was only one problem. There were other sources of swirling, twisting, curling microwaves exactly identically mimicking this imprimatur, the signature of the inflationary period. And the most humble substance of all, as I said before, dust, pervades the cosmos. In fact, it pervades most of my house space in my house.
Everywhere.
Every piece of electronics I
own. Kids, that's right. Yeah, we don't really have like a giant space end duster that can go out into our galaxy. And really, thank goodness for the dust, because we actually have, as you know from the Joni Mitchell song, we have stardust flowing through our veins. We have, as Carl Sagan put it, we're standing on this pale blue dot, this rock, this mote of dust, as Sagan described it. This giant ball of rock is really the eminence of a distant supernova, a past supernova in the distant past in our galaxy that exploded, and then the material within it congealed to make the rocky iron, silicon, etc., inside of our Earth's the planet Earth. And it also can be aligned in the Milky Way galaxy's magnetic field. The light, the heat that is emitted by tiny grains of dust, as microscopic as they are, in aggregate, when you've got planets worth and asteroid belts worth and just vast repositories in our galaxy, it can mimic the signal. And a few months after publication, we basically retracted the claim that we had made. I always like to point out, we didn't have like a front page, we didn't call a press conference. You never see that, right? Have you ever seen like big press conference tomorrow at NASA to retract the previous claim made by NASA?
Yeah, no.
It doesn't really happen. And there's a pressure on scientists, and it's unfortunate because, and I'll say, I myself, I'll just speak for myself, for a long time, I was driven by a desire to win the Nobel Prize. And it arguably was one of the reasons that I created the experiment. I'm very candid about that I wanted to make a discovery of all time, a huge discovery on a par with the origin of the universe itself. And that would clearly be worthy of a Nobel Prize. I didn't think I would get to see it, and maybe don't believe that would be, but it was certainly part of my motivation. And, I'm not ashamed to say that, but I think a lot of scientists are, and they're not honest enough to admit that it does motivate things. I mean, I was told very early on, I have to get the Nobel Prize or be eligible in some sense to win, to get tenure or to get the highest promotion in the University of California. It's actually true. To get a parking space at UC Berkeley that's next to the physics department, you have to win a Nobel Prize.
Oh my gosh.
The parking space says NL, Nobel Laureate. It's hilarious. But there are all these hidden signals and signs that go to young people. And I remember an early reader of my book, she's a science editor, but she had started off life as an astronomer, and her father discouraged her from pursuing a career in science as a scientist rather than a journalist. And he said, well, you're only a good scientist if you win the Nobel Prize. And she gave me, she said, I wish I had your book 10 years ago to give to my dad. And I felt just very emotional about that. But in the end, what ended up happening is, we retracted the claim. And part of it, as I said, it was driven in this fiercely competitive field of astrophysics. You don't think of it like that, but it is a competition. And there's only so much funding. There's only so much publicity. There's only so much recognition and only so many faculty jobs available. And so there is a huge element of competition, which is, in my mind, engendered, at least in part, by the Nobel Prize and some of the fatal flaws encoded within the Nobel Prize.
So you mentioned too, that you really like an experiment that has a lot of risk to it. I'm quoting somebody from my my research lab who said nobody here really knows what they're doing because they're trying to do something that's not been done before, And it really made sense of the fact that no wonder everybody does sort of have that sort of sense of caveat about everything because I don't really know, but we could try a thing. But it's really, that's what's happening when you're exploring a thing that doesn't have the answer yet. And it does require that risk taking.
Yeah. So geeking out a little bit, John Archibald Wheeler, who is, one of Feynman's, thesis or undergraduate advisors, he used to say things like, the job of a scientist is to increase the island of knowledge, within the ocean of ignorance. But when you do that, you're also increasing the coastline, of the border, which is this quasi state of you don't really know what's going on. And luckily, the area increases faster than the circumference, right? So in that sense, we do pursue the unknown. And the word science itself, it means knowledge. It doesn't mean wisdom. It doesn't mean creativity. It means knowledge. And there's no greater tool than science. And there's no greater show than This Week in Science.
Thank you.
You guys can call it This Week in Knowledge. But it's true. Yeah. It's the most delightful state to be in is one of puzzlement and befuddlement, because that's when you know that you have the chance to do something that no one's ever done before.
Yeah. So tell us what you're going to be working on with the Simons Observatory, and what are you going to be doing that no one's been doing yet?
So what's so exciting for me now is that the technology has improved thanks to the work of hundreds of young people around the planet. The technology that we are building is so extremely sensitive. We can detect the most faint signals from the early universe, and we can build massive numbers of these detectors. I'll just say, I got my PhD, about 20 years ago now. Actually, this is the 20th year or anniversary of my PhD. And there'll be parties around the world for that, undoubtedly. But at the Smithsonian and elsewhere. But the actual detector that I built was a single detector back in '99, and that made some nice. And now we're building an instrument that will have 60,000 detectors.
Wow!
And each one will be 5 or 10 times more sensitive than the detector I made. So we're increasing more and more rapidly. Yeah, there it is. We're increasing more and more rapidly than even Moore's law. So the progress of my colleagues at the National Institute of Standards and Technology in Boulder and at UC Berkeley and are building such phenomenally sensitive detectors and at scale that we can do things that no human being has been able to do before, because we have been limited by the amount of technology that was available. And so our goal is to build this instrument at one of the world's highest, driest deserts, the Atacama Desert of northern Chile. And the instrument we have is truly massive. We have one telescope. It's going to be 2 mirrors that each one is 6 meters in diameter. And it will be coupled to a detector system, which will be inside of there's that observatory there. That's the building. That whole building has to rotate on its axis, tilt up and down, and swivel around with an accuracy of holding a human hair out at a distance of 10 football fields. It's just an incredibly, incredibly amazing piece of engineering driven by scientific optimization, which is driven in turn by the desire to understand the composition and origin of the universe, and perhaps to shed light on this most mysterious question of the multiverse. That is the goal, and it just takes massive amounts of brilliant people from around the world to do it. So there are some of my students at San Diego, and working really hard on building. What's cool about this project is that you see there, all that stuff is built by those guys are, and gals are in their 20s, and they get to build this, $80 million observatory and the pieces from scratch, and they're actually using their hands to do it. It's not like, oh, we're just going to design something in some company and we'll build a detector. And I'm not, dismissing how hard that type of project is, but this is really hands-on, super fun to build. And people just really enjoy getting to work on this technology. It's phenomenal.
And the technology that you're working on, so it's a high altitude desert, you're, clear air, cold air, but at the same time, it's not space.
Correct. Yeah, to go to space would be ideal. But the problem is space missions cost at least 100 times more than a comparable ground-based mission. And in some cases, you can't get to space. You can't put that 50, foot tall building into space. It's just impractical in terms of, the logistics and space launch capabilities. And you see now, even with a telescope like the Webb telescope, which I know you guys have talked about it at length, and it's been delayed. That telescope is smaller, than one of the mirrors that we're building in our telescope, and that's doing it on Earth. So what we would love to do is, kind of a blend, and we have benefited from space missions, but we call this the poor scientist spacecraft, even though it's hard to cry poverty with a, $70 million, $80 million experiment.
And are what did you say, 60,000?
Yes.
Components? And so is the ability of shoving that many components in, detectors in, is it that they're smaller? Is it that transistors and everything that we use technically has gotten smaller?
If you look at, a cell phone camera there, so there's a tiny lens, which is, maybe a few thousand times the diameter of the wavelength of light that it's trying to detect. So for us, we're trying to detect light that has a wavelength of about 2 millimeters, so 4,000 times larger than visible light. So everything scales not as that length, but as that length squared. So to put, 60,000, imagine you can't buy a phone with a 60,000 pixel camera. Nobody's going to buy that, right? 60 megapixels, 1,000 times more. Maybe I'll get interested. But in these cases, these detectors work down near absolute zero. So you can't really do that with your iPhone and not void Apple Care warranty. So in our case, those detectors, you see those ladies and gentlemen working on the lab, they have to be cooled down to about 0.1 degree above absolute zero, 100 millidegrees above absolute zero. And at that temperature, these are what are called superconductors. They have no resistance to electrical flow of energy. And at that state, they're exquisitely sensitive detectors of heat, like the heat from the Big Bang. In addition, they have to be sensitive to different colors of light or frequency bands and polarizations. And that, remember, is what we're looking for, the swirling, twisting pattern of light emanating from the Big Bang.
And with stuff like LIGO, they're using triangulation, and they can get rid of all these variants, things that are just noise in the signal. There's heat all over the place on our planet. Everything booming in here. There's energy that's heat energy. So how do you deal with all that noise?
Yeah. So if you convert what room temperature is to Kelvin, it's about 300 Kelvin. The microwave background signal itself is 100 times colder. So if you heat something up to 300 Kelvin, it glows with a certain type of what's called black body spectrum, a heat spectrum. If you heat it up to 5,000 degrees, it starts to glow like the temperature of the sun in the visible. But going the other way, if you cool it down to 3 Kelvin, 100 times colder than the surrounding ambient temperature, it emits much, much less light and heat, which is a contaminant. But we have to go actually a factor of another, factor of 10 below that at least. That's why we get down to a fraction of a degree above absolute zero. At that temperature, the superconducting materials that we use in our detectors become very efficient, and they are very accurate and precise detectors of this heat. And so ultimately, yes, but there's no place in the universe that you can go to that has an ambient temperature lower than 3 degrees Kelvin, because we're inside of an oven. The oven is the very distant reaches of the universe that is thankfully emitting a very cold temperature of only 3 Kelvin. But we actually have to get colder than the temperature of that interstellar space in order to make these detectors work. So it's a real fun thing to do. And you see those people, those young men and women, that's really the greatest joy, is that they get to build this stuff, and they're going to be taking over. I'm just planting the seeds. They're going to eat the fruit later on when we actually get results and learn about the composition. We didn't have time. Maybe some other time we'll chat about these exotic particles called neutrinos that we're trying to capture with this telescope, and perhaps only be able to capture with experiments of this kind.
That's wonderful. So we are coming to the end of the first hour of our show, and I would love to know, what do you want our audience to take home with you about your work and your experiences? Like what key message do you think our audience would benefit from?
Well, I think that, in my line of work, you have to be comfortable and you have to be humble, but you can't be humiliated. In other words, we really face this potentially humiliating, crushing defeat, but we learn from it. We learned what we did wrong and why the mistakes were made, and we did make the mistakes. There's a book called "Mistakes Were Made, but Not by Us," but it was done by us, and that's okay, because we're people and we're human beings, and the object is to not make those same mistakes in the future, learn from, and in doing so, it really advanced that coastline of knowledge and the boundary deep into the abyss, and that's the most fun part of what we get to do. But it's also a great challenge, because you have to simultaneously not invest so much of your ego in what you do that you're going to be crushed by literal tiny grains of dust, but you're going to actually, be humble enough that they could crush you, as Gandhi used to say.
Be humble enough. Yes, absolutely. Thank you so much for your time tonight. It has been just
honored to be with you guys.
Yeah, it's just been great talking with you. Where can people find you online? Where can they find out more about your work and follow you?
Well, my book is online, Amazon, Google, etc., and all sorts of bookstores around the country and the world. There's a website that I have called briankeating.com. There it is. They call it the Twisted Universe there. There's me at the South Pole. And I give a lot of talks around the country, public talks, etc. And my schedule is there. I have a mailing list. And then on Twitter, I am Dr. Brian Keating, Dr. Brian Keating. And we set up, there's a little link there called losingthenobelprize.org. And that's kind of a side note. That's kind of like a moveon.org for scientists, in that we're trying to crowdsource a real movement that people will help us rectify the injustices that the Nobel Prize has conferred upon science, and make it better for its own good and for the good of all young scientists.
That is definitely something worth looking into. Thank you so much for sharing that. And again, thank you for joining us. And I for one would love to have you back on. It might be fun to have you. We could do a commentary on this next year's Nobel Prizes.
I was thinking the exact same thing. Yes, I was thinking the exact same thing. Yes, October we'll be able to do it, and we could do a, kind of like the Oscars, but with the Nobel Prizes.
With the Nobel Prizes, it would be super fun. Yeah, we always have a conversation. We always bring them up and the winners and everything. And
yeah, I would love that. Yeah, so let's definitely keep in touch. I will be following you guys as always. Thank you guys so much.
Thank you. Have a wonderful night. Thank you.
Good night, guys. Bye-bye.
Good night. All right, everybody, we have come to our break, and we are going to be taking a few moments to tell you a few things about TWIS. But we will be back for the second half of our show in just a few moments. If you wanted to get the name of his book again, it is called Losing the Nobel Prize, A Story of Cosmology, Ambition, and the Perils of Science's Highest Honor. That was Dr. Brian Keating. And This Week in Science will be back in just a few moments with more science. We've got Valentine's science. Stay tuned.
Things you've heard more than intuition. A line freeze that shows the way to go. New conclusion. The methods of hypothesis and patience are the only things I need. Put on a pair of goggles and go looking for the things I couldn't see. The answers lie somewhere within this
scatter plot. Hey, everybody. Thank you so much for joining us for another episode of TWIS. We are so glad to have you here. I would love to tell you a few ways that you can help support TWIS and keep us in podcasting business. Yes, This Week in Science relies on listener support. And one way you can do that, you can support us, first off, by heading over to TWIS.org. Oh, first thing, TWIS.org, we've got a new pop-up window. You will find there that if you have not replied to my Patreon message about this, you can subscribe to our newsletter. That's right, TWIS will be creating a newsletter that will keep you updated on all things TWIS-like. New shows, interviews that come up, also occasional articles, things that Blair and I, and maybe Justin, I don't know. He's a writer too. We'll see how it goes. We'll keep you updated on things that we're doing and things that we're thinking. And I hope that you enjoy it. And, if you can sign up, you can always delete it if you don't want to read it. But I ask you, go to twist.org and maybe consider signing up for our newsletter. It's coming in hot. Once you get there to twist.org, the ways that you can help us out, the subscribe button is a huge one. Subscribe, you click on that button, tell a friend to click on it, YouTube, iTunes, Google Play. Easy way to access TWIS on a weekly basis, aside from the newsletter. Also, you can support us with your purchases. We have a merchandise store. That's right, the Zazzle store. Click on the link in our header bar. It'll take you to Zazzle.com/This Week in Science, where we have all sorts of goodies with TWIS logos and images from previous Blair's Animal Corner calendars. Lots of things for you to peruse through. Do you need a cup for your coffee, a tote bag for your groceries, a cover for your phone, just a t-shirt that proclaims your Valentine's-y love for TWIS? Oh, yes, that's right. Make that purchase. A portion of the proceeds support this show. Back at twist.org, you can also donate directly. There's a yellow PayPal button. The yellow button takes you to a PayPal interface where you can donate one time, any amount of your choosing. If you want to donate on a recurring basis, an easy way to do that is to click on the Patreon link. It'll take you to patreon.com/This Week in Science, where you can click on the red button to become a patron at the level of your choosing. You will be charged on a recurring basis once per month. That's right, once per month. We will charge you the amount that you decide you are able to pay. And we send you fun gifts. That's right. And if you join us at the $10 a month level, we will thank you by name at the end of every episode. That's right. It's fun stuff. Support us. Get your TWIS. All the good times, everybody. We rely on you, and we really couldn't do it without you. From listening to being a part of the audience to helping us make the show happen, we couldn't do this show without you. Thank you for your support.
and explain things you've heard more than intuition. Collide reason shows the way to go. New conclusion. The methods of hypothesis and patience are the only things I need. Put on a pair of goggles and go looking for the things I couldn't see.
And we're back with more This Week in Science.
Yes, we are. And it is time for that part of the show that people have begun bringing us submissions once again. This week in What Has Science Done for Me Lately? Well, today's letter comes to us from, well, let's see if I can get past my camera there. Dale Moore, Minion Dale Moore has written in before, and he says, science has allowed me the luxury of contemplation. Science has allowed me the knowledge of my world, to be able to see the beauty of it all through the details of it all. Science has allowed me to be able to sit on a beach, mesmerized by the awesomeness of the ocean, knowing full well that there are more water molecules in a glass of water than there are glasses of water in the ocean. Science has allowed me to hold the sand in my hand and know that the sand does not actually touch me, nor do the grains of sand touch each other, but that we are all held slightly apart, suspended by the interactions of the electrons filling the surface. Science allows me to contemplate that even though I sit on the beach, I am mostly empty space, and if that space were removed, I would be reduced to the size of the grains of sand that stain my skin. I can gaze at a beautiful sunset knowing that the gorgeous sight is made visible by the light streaming into my eyes after a 93 million mile journey from a ball of plasma, and that it only took 8 minutes to get to me. But that doesn't diminish the beauty of the moment, it heightens it. It makes the moment that much more awe-inspiring because while I, a small bag of atoms, sit on this one beach, on this one small planet, in this ordinary system, in this average arm of this common galaxy, in this vast universe. I am here and I am alive and I can appreciate it for what it really is. All because men and women striving for truth, striving to know this place and our place in it have made it possible. Science has given me perspective and gratitude, and for that I am truly and forever grateful. Minion Dale Moore.
Nice. That has the
Beautiful.
makings of a song in it.
That's so poetic. Yeah, it's beautiful.
Yeah.
Yes. You know, we all need these words every once in a while. These words that can be created by the neuronal flashings in people's brains. And yes, perspective. Thank you, Dale. I really loved this. I loved reading this one. So thank you so much for writing in. And I'm really glad that science allows you this perspective and gratitude. Yes. I have gratitude for you and all of you. Remember, we need you to write in and let us know what science has done for you lately, whether it is a short poem, sonnet, haiku, a song, a short essay, a blurb, a pondering, a musing. Yes, amuse us with your ponderings. Send us a message. Facebook page. That's right, facebook.com/thisweekinscience, or email me at Kirsten@thisweekinscience.com. That's KIRSTEN @thisweekinscience.com. Let's keep filling it with your letters. I want to keep doing that. Let's talk some science now. It's time for science now. Oh, the world is ending.
Wait, what? Wait.
Happy music.
Wait.
Science now.
Okay. Hang on. Back up the song. Wait.
Oh, yeah. Wait, I just
ending?
kind of slipped that in there, didn't I? Well, no. It's a slow death. It's gonna be slow and good.
That's actually what I look forward to.
Like, so what's happening is kind of like, you know, your leg is falling off, but you're just starting to go, do I have pins and needles?
Wait,
Uh-oh.
what?
That's kind of where humanity is right now, is kind of the way I
So
feel
the
about
Earth's leg, what is that in the metaphor?
this. No, it's
Okay.
humanity's
Oh,
leg.
humanity's leg.
Yes.
Okay.
It's humanity. The Earth
All
is
right.
fine. The Earth is
Okay.
always fine.
Yeah,
All right.
This is
the Earth will survive us.
You're right about
believe it or
that.
not.
You're right about that.
So, a review published in Biological Conservation this week has made big headlines globally, as it should, as it has reviewed several studies from around the world, 73 historical reports of insect declines. They systematically assessed the underlying drivers of decline in these reports and have discovered that over 40% of insect species are threatened with extinction, and that's not great.
So I was listening to a comedy news podcast a couple days ago, and they had this story on, and they said, so the bugs are in trouble, insects are dying. I know that's bad, but I don't know why.
And this is something that we do need to talk about, because everybody, it's like, oh, I'm not being bitten by as many bugs.
Yeah.
I don't have to wash my windshield as often. If I do a cross-country drive, it's like, hey, I
Right.
made the whole way.
Okay.
I never had to clear the windshield. So
Right,
this
first
is
question,
not
how many bugs can you name that you've been bitten by? Really, the list is pretty small compared to the amount of bugs that exist.
It's
That's
a
true.
smear campaign.
Yep, it is a smear campaign. Bugs are essential to the functioning of this planet. There is the mass of bugs on this planet far outweighs the mass of vertebrates, and it underlies the food chain. Bugs are an incredibly important part of the food web, and we have seen we've lost numbers of honeybees since the 1940s, 1950s. We're at a fraction of what we once had, and people are like, oh, colony collapse disorder, but they're not talking about the just mass death of multiple species of honeybees that has taken place over the last 60 to 80 years. So bugs, we call them bugs because, they bug us, right? Insects. Insects are essential to the functioning of food webs. The majority of them are, not majority, but many of them are essential to our agriculture, in that they are pollinators and recyclers. And these, if we see a decline in a more precipitous decline in insects on this planet and don't do something about it, it is going to affect our ability to exist on the planet. So humanity, this is like the pins and needles stage. We should do something before our leg falls off. And so the question may come to you, what am I going to do about bugs? Well, one idea is if you have the economic ability, to buy organic, because pesticides, according to this study, are one of the main drivers. Agrochemical pollutants are one of the main drivers of these extinctions. That said, invasive species and climate change are also additional causes. And part of climate change is also environmental change. And in our human spread, as we remove what were once riparian areas, as we cut down trees and forests and replace them with houses and streets and roads and concrete that does not grow a plant that can support an insect ecosystem.
When climate change causes flowers to flower at the wrong time.
Yeah. And also the use of lawns. Lawns are big drains on our water system. Maybe get rid of a lawn and consider planting
wildflowers.
Local wildflowers. Exactly.
Native wildflowers. Absolutely.
Yeah. Don't be afraid of the bugs. We need to foster those bugs.
Good habitats.
Yeah. So anything we can do to help reduce this rapidity of climate change, and also to assist in the ecosystem maintenance of animals and these insects.
Now,
That's what we can do.
slight silver lining.
Yes.
When you do eliminate a lot of species from this planet, as has happened naturally a number of times, you open up a lot of niches for new evolution to fill into, for speciation to events, usually show up right after a mass extinction event. So we may be, even though we're looking at this from the perspective of humanity decimating life on this planet to a great extent, we may actually be creating a new speciation event as we eliminate life forms across ecological niches for a foreseeable future. This may actually be, I know it's not fun being in the point where things are going down.
You mean speciation as in humanity dies out and there's
a new
human species that survive?
That's what I was going to say is when you say right after, after is like tens to hundreds of thousands of years.
Which maybe a million years.
But way after we've died because crops won't grow.
Right. But the future squid sentient life forms or whatever takes over after, we'll look back at the almost Cambrian like age of expansion of life that took place after the humans finally died out.
Yeah, I money's on snails and slugs.
You like the snails and slugs? Okay.
I think they might have it. They might have what it takes.
They might have what it takes. Yeah, this is just one among many stories of issues that there needs to be a very concerted global effort to discuss how we are going to, redesign our agricultural practices. We're losing topsoil at a ridiculous rate, which is again going to reduce our ability to grow food for our growing human population. It's dust in the wind, baby. Dust in the wind. Yeah. So the topsoil's going, we're having water redistribution because of different weather patterns and the climate changing. So water is going to be less available in some areas than it has been. Agriculture will become more difficult to do. Insects are dying and moving. This is all tied in together, but the bugs on the windshield are one of those big indicators that to me, we're done. There was a Catherine Hayhoe, a climate scientist who is very active on Twitter. She posted the results of a survey. I think it's a Pew survey looking at attitudes related to climate change. And it's basically alarmed, concerned, somewhat concerned, don't really care, and down the line. And there used to be a lot more people in the didn't care or in the kind of somewhat concerned group. And those individuals have now shifted and more people are highly concerned and alarmed. And really looking at the numbers, the number of people who don't really care and aren't looking at this are in the minority.
But what I think is so interesting about this is
what I'm saying is the numbers of people, we are at a point where things are shifting and we can do something.
Yeah. So I think what's super important as people are getting more engaged is that we make sure that they can connect the dots from the initial cause, which is the burning of fossil fuels or whatever it is, right? And the final result, which in this case is the decline of insects, and connect that back to humans. Because just kind of like the joke that I made at the beginning about this comedian who said, okay, insects are disappearing. And I know that's bad, but I don't know why. I think that's part of this conversation, right? Is making sure that these findings are communicated to the general public in a way that is relevant and pressing, instead of just the bees are dying and we're all going to die. It's okay. So insects are pollinators. We depend on them for food. Here's what you can do to make sure that pollinators are still around so that we still get our food, right?
You butterflies? Well,
yeah.
plants that like butterflies too.
Yeah. So I and not to like put too dark a footnote on this. Even if it wasn't for global warming at all,
Yeah.
even if
Mhm.
this
This is-
didn't exist, what we're doing is unsustainable. So this is a nice thing to rally around and utilize to connect those dots, as you're saying, Blair. I think that is absolutely necessary because it's something that is global in its affects, and therefore should be able to, like we were talking about, like cosmology being something people around the world can all engage in because we all have the same view. This is something that could be utilized as a good rallying cry around all of those other downstream unsustainable issues that in some ways may be more impactful even.
Absolutely.
that people may listen to.
Yeah.
Yes.
Yeah.
And then on to a happier, more, Valentine's Day appropriate story. Just in time for Valentine's Day, researchers have published a dinosaur discovery in the journal PLOS One. It is a dinosaur with a heart-shaped tail. Yes. The bones belonging to this dinosaur's tail are they are in the shape of a heart. And this is a dinosaur found in Africa, which is an area not historically thought to have had these giant titanosaur dinosaurs, which are usually from found in South America, or that part of land that is now South America. But these dinosaurs are related to titanosaurs in other parts of the world, and have the bones of their tail are a very interesting shape. They're huge bones for one, and these are massive, massive dinosaurs. And for two, they really are. It's not that the end of the tail is shaped like a heart. It is the bones themselves inside the tail that are in the shape of the heart that give the tail something of a heart-ish top and then a tapered heart bottom like underside.
Okay.
Yes.
So at first, when I thought it was very obviously heart-shaped, I was wondering, when did they find this? And how long have they been sitting on it?
Exactly. Like, we should publish in December. No.
No.
We gotta wait. This can only be published right before Valentine's Day. That's how we're gonna do this.
Yeah.
That's how we're gonna roll it out.
The skeleton is from the Cretaceous, so it's been hanging out waiting
a while.
For a while. It was discovered in 2004 when part of the skeleton was found in a dry riverbed overlooking an area called, it's a Matuka is the area in which it was found in Africa. And the excavations continued through 2008. And then you know how things go, working on the bones and figuring out exactly all the details of how things fit together and the phylogenetic relationships of the animals. This dinosaur has a very long name. It is derived from Swahili. The Swahili means animal of the Matuka with a heart-shaped tail. So it's specific
very straightforward.
Very straightforward. However, I don't Mnyama tuka moyo wa mkia.
3 more times.
Oh, no.
This is I'm going to show those of you.
Did you even get all the way through it? Like, how long is this name? This is not going to be any 8-year-old's favorite dinosaurs just because of this.
No, so the name itself,
except for the one that does learn how to pronounce it, and because he or she learns how to pronounce it, that's going to be their favorite because they're the only one that really.
Hawaiian fish, humu humu nuku uapua. Exactly. Someday I will have the dinosaur name down, but it is appropriate in that it's derived from Swahili and it is appropriate to the region, and so the nomenclature is fantastic, but it's going to take a while for people to wrap their tongues around this one. And I don't know that the pronunciation key is any better than the actual.
Doesn't look like it's helping.
Bless them for trying.
Umnyamwamtuka moyowamkia.
I think you probably nailed it right there. I think that I'd buy it.
I'll buy that for $1. Tell me a story, Justin.
Oh my gosh, is it story time for Justin? Okay. So yes, what would Valentine's Day be with Justin without a Neanderthal story? One small step for man was, of course, preceded by many, many small steps by Neanderthals. And now, thanks to scientists from the Gibraltar National Museum, alongside colleagues from Spain, Portugal, and Japan, we have found that some of those steps of meandering Neanderthals were captured in rock print. This is published in the journal Quaternary Science Reviews. Prints found in the Catalan Bay sand dune of a time when the sea level was 120 meters below what it is presently, and a great field of dunes that stretched out from the Rock of Gibraltar in Gibraltar. Gibraltar's Gibraltar. It's not in anywhere. Unless the UK and Spain have a war at some point, it will stay just Gibraltar, but you could say it's the southernmost tip of Iberia. The work started 10 years ago when the first dates were obtained. It is then that the first traces of footprints left by vertebrates were found. Subsequent years, the successive natural collapse of the sand has revealed further material that has permitted them to do an even more detailed study, including some new dating techniques. So they identified footprints that correspond to species which are known from fossil material already to have inhabited Gibraltar. They identified red deer, ibex. I don't know what this animal is. Aurochs? Aurochs. What is that, Blair?
Auroch.
Oryx?
Oh.
Aurochs.
Oh, it's a huge cattle type thing.
Okay.
Used to be common in Europe, is now extinct. It was a wild animal, not domesticated. It looks like a giant cow.
Wow. They also found footprints from leopard, which is the leopard in Iberia? I didn't know. Straight-tusked elephant. In addition, scientists have found the footprints of a young human who they think is a Neanderthal, which dates to around 29,000 years ago, which would coincide with Neanderthal dates from a nearby Gorham's cave. If confirmed to be Neanderthal, these dunes would eventually then become only the second site in the world where Neanderthal footprints have been captured in stone, the other being Vartop Cave in Romania. Slightly interesting, at least if the rock print turns out to be Neanderthals. Looks like they had a giant big toe, like way bigger than the rest of their toes, which would be very interesting if that's already in the fossil record somewhere. Research was supported by the government of Gibraltar under a project, the Caves project they have ongoing, as well as with scientists from the Spanish EU project. So yeah, a little bit of insight there. A little footprint. I love it whenever we see these hominin footprints captured in stone, whether they're of our current human ancestors or the more ancient relatives. It's always fun that something can leave that much of an indelible mark on the earth, that we can find it all this time later.
Yeah, footprints from that long ago blow my mind. It's just this mind-boggling, like, wait, what?
Then my next story will really blow your mind.
Awesome.
Life on Earth. We already talked about how wonderfully improbable it all seems. The origin of life on Earth is a mystery wrapped in an enigma, likely hidden at the fringes of an ancient ocean, which happens to be exactly where they found what might just be the oldest example of multicellular life on Earth. So multicellular life, other than, not just these like the traces that we've seen of bacteria and the like that we've possibly been able to date to about 3 billion years old on a 4 billion year old planet. That's pretty soon for life. Sorry, multicellular life, though, that more complex life that eventually leads to fish and us and plants and everything. It's considered to be very old. 600 million-ish years old, in fact. Which, compared to 3 billion for just single cells, that's still pretty quick. So life is very old, and it started pretty much right away on the planet. However, the venture into the unknown and into the anything new information worth mentioning at a cocktail party is just getting started, because newly discovered fossilized slime tracks suggest multicellular life could be much older than previously thought.
Snails! I told you.
Yeah, they started. The preservation of fossilized tracks, quotey voice here. Preservation of fossilized tracks, or trace fossils, suggests that multicellular organisms that could move around to reach food resources may already have existed 2.1 billion years ago. More than 1.5 billion years older than previously thought, explained Kurt Kornhauser, professor of the University of Alberta's Department of Earth and Atmospheric Sciences and co-author of the study. Fossils found in the Francevillian series formation located in Gabon, Africa, are likely the result of ancient mucus trails left by multicellular life that could have been just a something akin to a modern amoeboid cell. And these tracks could have been left as they went looking for food. Samples range from 6 millimeters across to 170 millimeters in length through the sediment layer. Despite the small size, though, it's been creating a rather large controversy. This is more Cody voice from Kornhauser. The question arising from this research, then, is why do we go 1.5 billion years before we see similar features in the rock record? We don't see anything like this again until 585 million years ago. Some speculate that this early emergence of complex life went extinct due to some environmental factors. So this could have been like one round of evolution that then just got eliminated. Others, though, are suggesting that similar fossilized traces may have existed, just didn't get preserved, or simply have been found but have gone unnoticed. Quotey voice, even more of Kornhauser. The broader community has a right to be skeptical about the interpretation. However, one of the current paradigms relating to the evolution of multicellular organisms is oxygen availability. And 2.1 billion years ago, there was no shortage of oxygen in shallow marine waters. So another layer to the research that's going to be coming up. They're going to do more examination of well-oxygenated shallow marine environments in the time period between the 500-ish million years and the 2.1 billion year period to see if it fits with where they found multicellular life other places.
Yeah, because we just dig where we dig, right? We see the rocks where we see the rocks, and it's not a continuous history of the Earth that we have and life's development on it. And so maybe we just haven't looked in the right place to have the right evidence for that time that occurred between 2.1 billion years ago and 500 million years ago. Yeah,
the Earth plows everything under in time, right? So the when we found like 3 billion year old rock formations that were haven't been devoured deep into the crust, it's a rarity that we even get back to rocks that we can actually date to being that ancient and still accessible from the surface. So when we find these traces, they're a sample within a tiny sample, within a sample of what's even available to see, which should be actually much more encouraging than I think we proclaim them, because the fact that we have a sample that's 2 billion years old that shows a trace, and we don't have 2 billion years old samples to look through all the time, should tell us it's probably not a one-off. It probably was everywhere.
Well, I mean, when we look at fossils of soft-bodied animals, we know that it's really unusual, right? Because anything that's squishy, that doesn't have some sort of exoskeleton, getting a fossil out of that is like a flash in the pan. It's really more telling than it should be, just as one item, because of this, because it has to kind of represent this larger group of animals that weren't preserved. So if you're talking about slime, that's really hard to be able to capture in a fossil. So especially a very, 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 very small piece of slime. So like, it's absolutely. I agree that this has to be. It can't be a fluke, unless they're identifying what it is incorrectly. Right. That's the only question.
And which has happened before. Like this is a debate that's gone on. Like a geologist might look at the same thing and say, there's a way to form this geologically that just would make sense enough to eliminate the more impossible type idea. Right? I mean, that's been a conversation about some of the 3 billion year old fossil finds. Not all of them, but on some of them. So this is again one of these fun things in science where science isn't only about being right, it's also about trying to prove yourself or the other person wrong, which I love the fact that the researcher who's the co-author of this study actually points out that the other side has a very good argument to make. He's like in the game. He's like he's totally understands that they can be refutable, the evidences that we find.
This is why I feel like sometimes science and what makes the media successful doesn't always mix well, right? Because you want these big grand statements that become headlines, kind of like what we were talking about at the beginning of the show. But to say like, oh, well, but this is slime that might mean multicellular organisms are way older, but also
the other guy has a great point. Nothing.
As someone else pointed out, it could be nothing at all. Like, that's not a headline.
Yeah.
But you know, those were some pretty good Valentine's Day headline stories right there. Footprints in the sand left by Neanderthals, maybe chasing a lover or food or whatever. And slime. And now it's time.
Is it
Blair's Animal Corner
with Blair?
She loves our creatures, great and small. Biped, millipede, no pet at all. You want to hear about animals? She's your girl. Except for giant pandas and squirrels. There's Animal Corner.
What you got, Blair?
Oh my gosh. You know what? Love, it's for losers.
What?
Sorry, everyone. I know tomorrow is Valentine's Day, but love is for losers. It's science. A recent study looking at, this is actually a cricket, the two-spotted cricket, demonstrated that in some cases, female choice does not depend on victory in battles preceding mating process. Instead, the losers may be the winners in the end. Yes. So love is for losers, but in a good way. Okay. Like the fight between males, the act of mating in crickets is preceded by a period of mating behaviors. They have sound, they have communication, they have movements that they make. So with fighting, it's antagonistic behaviors. We've talked about this with things like deer on the show before. But so they kind of size each other up, and then at some point they might end up actually fighting, biting, wrestling, all that kind of stuff. But mating also involves sizing up one another, making calls. So there's similarities there. And
I
scientists...
just got a headline out of this. Women appreciate men who can lose arguments.
Yes, there you go. So there might be something to that, Justin. Science identified 19 behavioral elements that these crickets did during courtship, and then they sorted all these males out into different statuses. So they had 2 rounds of combat in the absence of females for the
fight.
yes. So only absolute champions and absolute losers were selected for mating. So those who refused to fight was one group tossed right out, or if they won and lost or lost and won, they were also tossed out. Only those that lost both times or won both times were sent into the second stage of the experiment,
where they were paired up, not a fight cricket,
with females. Exactly. The aggressive fighters were still kind of in this like kill mode, and so they perceived the females as a potential rival, and they showed aggression. They gave signals of attack. Some of them actually started beating or biting the females. What? So as you might imagine,
don't act surprised. That happens with humans. Like, don't act too surprised, Kiki.
So this behavior,
humans do these things.
Quote, interferes with further courtship.
Okay.
Unlike the alpha males, the losers began courtship as soon as they saw the female. They were ready to switch in to romance mode. So the winning crickets had a high level of hormones responsible for aggression, as you might expect, and they had more trouble immediately switching into that courtship mode. So they looked at all these different types of signals, and they measured the time between the start of courtship and mating directly. And so they really saw that these losers, quote unquote, in battle were far more successful in getting to the point of mating, which is the ultimate game here, right? So this is a weird thing where in a lot of biological wisdom with mating displays, with fighting for access to females, the most virile male, the male with the greatest levels of male hormone, the males that are most successful are usually the ones that we expect to have the most babies, to have the best job passing forth their DNA, and to have the best access and success with mates. But this is a case where the losers actually did far better. So of course, this is a stepwise thing, right? So they just did the extremes. I think in the next step of this study, if they started to look at those in the middle, in those gray areas, I'm guessing that's who's going to have the best success, or those that win sometimes so that they get better access to females, but aren't so kind of roided out so that they can't switch to the romance.
This is also a very misogynistic study because it's looking at all the male 2-dot crickets.
Yeah.
What if the female crickets are just have a more nurturing attitude? So it's like, he needs me more.
Yeah.
It could just be. Yeah. They could just be more caring.
The sensitive cricket is more sexy.
He needs my help more. That's why I'm going with him.
I really like the cricket who didn't want to beat me up. I think
exactly
what's going on there.
Clear. Yeah.
Yes. I would really like a life partner who doesn't try to bite and hit me the second that I walk in a room. That would be great. So this is an interesting study that kind of makes us just reassess some of the fundamental expectations in mate choice, I think. And so, the researchers say that insects are a great suitable model for starting to learn these sorts of things because in laboratory conditions, their behaviors remain very consistent to how they are in the wild. So in this case, for example, crickets, they don't really see a difference when you take them out of the wild and put them in laboratory conditions. Of course, with other animals, you're going to have a harder time replicating how 2 male bucks would have competing antagonistic behaviors, fight, hit their antlers together, then have access to a female. Like, that's much harder to replicate in a laboratory. But from this sort of thing, you can potentially go out into the field and see things that are happening behaviorally. And this also might explain why you get kind of these gradients of behaviors, even though you would expect that over time, evolution would give you just all of these super aggressive males. This might be why that's not the case.
Yeah, absolutely. Would minimize their frequency in the population.
Yeah. So,
For
gentlemen,
sure.
this Valentine's Day, take a note from the crickets. You know, be nurturing, be sweet.
out.
Yeah,
Yeah.
just chill out, man.
Yeah, maybe don't get in
Lose
that
an argument
fight.
once in a while.
Yeah, lose an argument. There we go.
A better day to lose arguments than Valentine's Day.
And so often in studies that I bring into the animal corner, there's studies on animals that have implications potentially for humans. I have something that was a study on humans that I think actually have implications for animals that weren't even mentioned in the article. So I'm really excited to bring this to the show today. This is a story about oral contraceptives and how they may impair women's recognition of complex emotions. So we know that oral contraceptives have, they are hormone based, right? And so we also know that hormones, these same hormones that are in the oral contraceptives, have previously been shown to impact certain recognition of emotions in other people or animals or all these sorts of things. So these progesterone and estrogen, we know they affect emotion recognition in humans and in other animals. So this is not a surprise in theory. But this is actually a situation where they took they took a group, it's a small group, 42 oral contraceptive users and 53 non-users. And they administered a special emotion recognition task. They tried to pick emotions and expressions that are hard to identify. And they found that the oral contraceptive users were around 10% worse on average than non-users in deciphering the more difficult emotional expressions. And this kind of raises a larger question about what these oral contraceptives are doing to our social emotional processes in humans. So again, this is a very small study. It's self-selecting because they didn't take people who weren't on oral contraceptives, test them, put them on oral contraceptives, test them again. No, these are just people who are on them, who are not. So there's many further levels to this that need to happen before there's any clear identifier of how much this affects and what specifically this affects in humans. Yeah,
Is
Justin?
it possible that just they were having more sex? And that's why they like the complex emotional thing wasn't as readily apparent or important to them.
What?
I'm
I mean, if
not
you're
sure how
saying
those
they're
are connected.
already on oral contraception and the other group isn't, and you might associate with the amount of sex somebody is engaged in with the fact that they're doing active steps for contraception and the other group isn't.
What does having
But that
sex
doesn't-
have to do with identifying emotional expressions?
Exactly. That's why this is so fascinating, even with its tiny subset of.
Okay, so that is a very different manipulated variable, but I understand you are just trying to imply that there are other variables in play. I get that.
But maybe the desired, maybe the heightened state of attempting to differentiate emotional states is more important in attempting to attain mate selection versus you already have a mate. Now you can kind of like resource down a lot of that tuned inness to people's current constant emotional states. Because now maybe it's like, nah, I don't care.
I totally get what you're saying there. I think that, however, there are a large number of women who take oral contraceptives who are not taking it for sex.
Yes.
They take oral contraceptives for just control of their menstrual cycles. For there are some women with
Endometriosis.
Endometriosis, where it's an issue, and the pill helps to ameliorate some of the symptoms.
If you're at high risk of ovarian, uterine, or colon cancers, they'll put you on it to reduce your
50 samples.
It manipulates because they manipulate hormones.
But 50 samples, right? Approximately
so you
50
don't know
people.
why.
So I mean, like this is too small. It's too small a sample size.
Oh, absolutely, absolutely.
Yeah.
But we do know, like I said, we do know that these hormones that you are taking affect social, emotional.
There have been studies in the past that we've talked about it previously, about these social emotional effects.
Yeah.
One study going way back that still needs to be replicated, in my opinion, is the one that suggests women who, when they go off the pill, aren't as attracted to their partners if they met their partner while they were on the pill.
Yeah. Which that one has to do with scent, doesn't it?
Yeah,
I thought that one was about scent.
But this is a matter of these oral contraceptives control hormones within the body, and hormones are involved in just about everything, and to a large degree in social, emotional, psychological states.
Right. So there's a bunch of stuff going on here. Further studies are required. Every researcher involved in this study has said further studies are needed. So they're just saying that this is an initial look. But I think that there's a couple things that I just want to mention before I go on to my crazy theories from this point. But this is not to say that oral contraceptives are bad. This is not to say that they need to be looked at before they're administered. They are a huge life-changing thing for a huge amount of women. And so
why it's called the pill? Even though there's lots of pills. And everybody knows exactly which pill you're talking about.
The invention of oral contraceptives for women has been credited with the second renaissance of women in society in a lot of ways. And so I'm not going to stand here and say that, the pill might be messing with your brain. Don't take it. No, I'm not saying that. What I am saying is that there is still a lot for us to learn as we have been taking this. And so, first of all, hey, there are oral contraceptives for men that aren't out there. What if they don't affect men, but oral contraceptives for women do affect women? Maybe that's something we need to be looking at, right? But also there are other options in contraceptives for women for some women. And so this might be part of the conversation. If somebody notices that they're foggy, I can tell you right now, on a personal note, I was foggier when I was on oral contraceptives. And when I went to a different type, it was like this fog had kind of lifted. That's not scientific. I can't tell you exactly what was happening, but anecdotally, this is a thing that people talk about. And this might be exactly what that is. And so if there are other options for people who have adverse reactions, this might help us identify that. Now, all of that aside.
Yes, I want to know what you think. Tell me about the animals.
Oral contraceptives are used in captive management of animals and in research projects for all sorts of studies. And they are not considered as a potential confounding variable in a lot of research studies when you look at social dynamics. If you think about primate groups, there's all sorts of studies done on primate groups, but they have to give contraceptives to some animals to control their population in that group. This is something that we might need to look at. Also, in zoos and in wildlife rehabilitation centers, they give oral contraceptives to animals that live in packs, that live in social groups. This is something that might be a big deal.
So it would make observation of this animal behavior maybe more applicable to modern human society, but less applicable to that wild type animal society.
But also, if you have a pride of lions that live in a zoo and all of the females are on oral contraceptives, and you take one of them off because they have a breeding recommendation, and suddenly they're not getting along with the other lions the way that they were. There's lots of things going on here. that could have an impact to captive management of animals in a pretty interesting way, potentially.
Yeah.
I kind of saw this kind of light bulb over my head that actually a lot of people don't realize a lot of animals are on the pill.
I don't think many people give it a second thought. Yeah.
Yeah, absolutely.
Fascinating.
Yeah.
Something to think about. How
Mhm.
is that affecting the social interactions of the animals we give the pills?
Mhm.
How is it affecting our research? Inquiring minds would love to know. We'd love to know. Hey, do you have drinking plans for Valentine's Day?
What day of the week does it fall on?
Tomorrow.
It's a Thursday.
Yes.
Yeah, it's bowling night for me, so I'm gonna have a beer or two while I bowl.
Okay, well, beer. Have you heard the saying, beer before wine is fine. Beer before, what is it?
It's
Or liquor
here's how it
before
goes.
beer.
Beer
Wine
before
before
wine is
beer.
fine.
Never
Wine
fear.
before beer, you're in the clear.
There we go.
Hard then soft, you're in the loft. And then soft then hard. Yeah, you've been trying too hard.
Beer,
Yeah, it's always worked out
beer
fine.
than liquor, you've never been sicker. Liquor than beer, you're in the clear. Those are mine.
There we go. Anyhow,
I
some
always said well. I
researchers
don't know why that is.
researchers just published a study in the American Journal of Clinical Nutrition, really just putting that to the test. If you have one before the other, does it really matter?
Oh, can I guess?
I would love to have you. It doesn't. Yeah, you're right.
So-
you're right.
so-
It doesn't matter.
Okay, so I don't know how they did this test, but I will say, but
No,
part of the wisdom behind that would be how quickly alcohol takes effect.
Mhm.
And
Right.
so if you've been drinking the beer before liquor or before soft before hard, you've been drinking and you've put up a little bit of drinking, but then you've done heavier drinking after. It's building off of that, and you may not have noticed how far you had gone. That's, I think.
Yeah.
But now there's been a study.
People should know how they feel the next day, regardless. And anyway, there's been a study. 90 people, researchers got 90 people tipsy. They were given control groups had either beer or only wine. And then study group 1 consumed beer up to a blood alcohol net level of about 0.05% drunk, and then wine to a blood alcohol of 0.11%. And then study group 2 did wine to 0.11% and wine to 0.05% and then drinking beer up to 0.11%. And they switched them all around later to make sure it was all mixed up nicely. But it didn't matter. Everybody had the hangover severity as it was assessed by the acute hangover scale rating on the day following each intervention. Pretty much if people were intoxicated, they had a little bit of a hangover, and it didn't matter which was first. Didn't matter.
Okay. Also,
Doesn't matter.
this is nowhere near the actual level of drinking at a college party. This is just like nowhere
close.
saying,
Yeah.
not
0.11% is a decent amount. I mean, that's
Definitely past buzz to drunk, probably.
That's drunk. Mhm.
Yeah.
Yeah. Yep. Anyway, other news at the end of the show here. Ultima Thule, which researchers and people have been saying, oh, it looks like a snowman. It looks like a peanut. It's this object that New Horizons found floating out past Pluto, and oh, it's so cute. But the reality is it's like the pancakes that I make. It's kind of flat and lumpy.
Oh.
It's not spherical. They thought it was spherical because of a trick of the angle, but upon observing the background stars in the images and how they blinked out as the object passed in front of them, researchers were able to determine that it wasn't as much of a sphere and was actually a bit more of a flat pancake. Ultima pancake. This is what I will call all of my pancakes from now on. You think it's lumpy and flat? Well, yeah, it's an object from out beyond Pluto. This is science pancakes, people. You'll love them. And then my final stories are from Mars. We've talked before about Mars 1, the mission to get people out to Mars.
Oh, yeah,
Right? We've
yeah.
interviewed people who
Yeah.
were trying out to be one of the Mars 1 crew, and it was supposed to be this big, reality TV show, get them all out there, all that. Anyway, they're going bankrupt.
Oh.
They really wanted to do this thing that's really hard, and they're reassessing their options at the moment. Anyhow, but in terms of reassessing options, the rover Opportunity will assess its options no more. NASA will no longer communicate with Opportunity after a giant dust storm last year covered its solar panels, we presume, with dust, and took away the ability of the rover to recharge its batteries. They have been trying for a long time, several months, to regain communications with Opportunity, and finally today have decided that communiques will be no more. 15 years of exploration. Opportunity covered over 45 kilometers of the surface of Mars. A brilliant little rover what was it? It was one of the rovers that was supposed to have like a
6
year-long
months.
mission. 6 months?
6 months.
15 years, and there's
Yeah.
still the Curiosity rover. It's amazing. We're on Mars. We got robots on Mars.
And, one decent windstorm to knock off the dust, and you might kick some dust off the project. Might start it up a little bit. You never know.
Or maybe
Well,
Curiosity will bump into him and kind of blow off the dust.
Right,
but there's also going to be
tiny.
Oh yeah, super.
But there's also going to be other probes going out, with more advanced abilities and things. So, but yeah, it was a 6-month expected project. Stunning how awesome NASA is in their overbuilding of things.
It's amazing. I love you, NASA, for your overbuilding.
Mm-hmm.
Yes.
I mean, it takes so much money to get it up there. I appreciate that.
No, it doesn't.
They have.
No, it doesn't.
It's nothing, huh? It's chump change.
No, like we had that interview with one of the people running. Was it Curiosity? But it was like the entire project was the cost of like 3 houses in Davis. I mean, we talk about it being an insane amount of money, but then you're like, well, actually, that's really not. You're just massively underfunded.
Yeah.
Exactly. Yeah. Yep. They do well on a shoestring budget.
Yeah.
Does anybody else have any stories for the end of the show?
I'm all done.
No more news? No more news, everyone. All right. Well, I am having an issue connecting to Patreon. So I am not going to be, they're down for maintenance. And I use the website to be able to read the names of Patreon sponsors. So I apologize. I am not going to be able to read. Oh, nope. Just now it came back. Yes. Da-da-da. I have been refreshing it for the past 10 minutes and trying to extend the end of the show. I've got it. Come on. You can do it. You can do it, Patreon. You can load it. Getting there. Yes. I've got it. Okay. We can do the end of the show now.
Yay.
All right, so we have made it to the end of the show. I would love to say thank you to everyone for enjoying the show with us tonight. Happy Valentine's Day to all of you. Happy Darwin's birthday to everyone. Happy International Day of Science, of Women and Girls in Science. There were so many great days this week. So many wonderful sciencey days. And I hope you enjoyed them all. There will be more to come next week when we are back. Everyone, thank you to Fada for helping out with show notes and the chat room over on YouTube and our social media. Thank you so much. Thank you to Identity4 for helping to record the show. Appreciate you allowing us to have audio files for the show. Gord McLeod, thank you for helping in the chat room, keeping everything happy, keeping it running in there. I appreciate that. And thank you to our Patreon sponsors. Thank you to Paul Disney, Richard Onimus, Ed Dyer, Stu Pollock, Philip Shane, Ken Hayes, Harrison Prather, Charlene Henry, Joshua Fury, Steve DeBell, Alex Wilson, Tony Steele, Craig Landon, Mark Mazzaros, Jack Matthew Litwin, Jason Roberts, Bill Kay, Bob Calder, Time Jumper 319, Eric Knapp, Richard Brian Condren, Dave Neighbor, Aiden Jeff, Stefan Alberon, John Ratnaswamy, Dave Friedel, Daryl Myshak, Andrew Swanson, Paul Ronovich, Corinne Benton, Sue Doster, Dave Wilkinson, Ben Bignell, Richard Porter Noodles, Kevin Reardon, Christoph Zuknarek, Ashish Pants, Ulysses Adkins, Sarah Chavis, Artyom, Rick Ramus, Paul, John McKee, Jason Olds, Brian Carrington, Christopher Dreyer, Lisa Slazewski, Drim Depot, Greg Riley, Sean Lamb, Ben Rothig, Steve Leisman, Kurt Larson, Rudy Garcia, Marjorie, Gary S., Robert, Greg Briggs, Brendan Minish, Christopher Rappin, Flying Out, Aaron Luthen, Matt Sutter, Mark Hessenflow, Kevin Parachan, Byron Lee, E.O. Thank you for all of your support on Patreon. And if any of you out there are interested in finding out more about Patreon, you can find information at patreon.com/thisweekinscience or just click the Patreon button at twis.org. And if you're over there, maybe recommend it to some of your friends. On next week's show, we have more physics coming for you. We are going to be speaking with a wonderful researcher from the Fermi Lab about a big Antonella palmese, who will be telling us some amazing things going on at Fermi Lab and big picture physics. So we will look forward to that next week during our normal showtime of 8 p.m. Pacific time on Wednesday. And is there anything else? Oh yeah, twis.org/live is where you can watch it live and join the chat room. But if you can't make it, don't worry, because past episodes end up on our YouTube channel and at twis.org.
Thank you for enjoying the show. TWIS is also available as a podcast. Just Google This Week in Science in your iTunes directory. Or if you have one of the mobile type devices that are going around, you can look up TWIS, the number 4 droid app in the Android marketplace, or simply This Week in Science in anything Apple marketplacey.
For more information on anything you've heard here today, show notes will be available on our website. That's at www.twis.org, where you can also, while you're there, make comments and start conversations with the hosts or other listeners.
Or you can contact us directly. Email Kirsten at thisweekinscience.com, Justin at twistminion@gmail.com, or Blair at blairbaz@twis.org. Just be sure to put TWIS, TWIS, somewhere in the subject line. Otherwise, your email is very likely to be spam filtered into oblivion. You can also hit us up on the Twitter, where we are at TWIS Science, at Dr. Kiki, at Jacksonfly, and at Blair's Menagerie. We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, a haiku that comes due in the night, please let us know.
We'll be back here next week, and we hope you'll join us again for more great science news.
And if you've learned anything from the show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science.
This week in science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. This week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. 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 I've got one disclaimer and it shouldn't be news. That what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just get understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. And This Week in Science is coming your way. So everybody listen to everything we say. And if you use our method instead of rolling a die, we may rid the world of toxoplasma. Got the eye. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. 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 I've got a laundry list of items I want to address. From stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought, and I'll try to answer any question you've got. But how can I ever see the changes I seek when I can only set up shop 1 hour a week? This Week in Science is coming your way. You better just listen to what we say, and if you learned anything from the words that we said, then please just remember it's all in your head. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. 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 This Week in 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 Science.
I keep forgetting to push the right buttons. We're in the after show. I'm tired. I'm gonna stop the screen sharing. Stop the screen sharing. Go to twist.org if you want to sign up for our newsletter. Yeah.
When do you want to try to plop this thing?
Plop? To plop newsletter.
Yeah.
How
How many people do we have on the list right now?
About 70 or 80, I think.
Okay.
Yeah.
Do we want to do a
That's a nice
social
little
media
number.
push to sign up, and then I can try
We could start pushing it out for March. Do you think that's reasonable? Give us a couple of weeks to throw a couple together and try a template and
I could send a like a beta test out, just a short one on Friday, because Friday is Hippo Day.
It is Hippo Day.
What is it? International Hippo Day. I was thinking I could just write an ode to the hippopotamus and send it out.
I believe you should do that.
Okay.
I think that would be great.
Great. I'll work on that. I'll try to send it out on Friday.
It's
my
Hippo
goal.
Day. Yeah, I can, and we can do something like I was looking at the calendars and I was thinking, it'd be nice to kind of theme up different weeks with different newsletters with stuff, the days that are happening,
Mhm.
our thoughts about those, or if there's like some kind of something that we've done, like, if we like how it looks and it works. I can talk about, I'm going to the AAAS conference this week, and there's going to be a lot of talk of climate change and science communication and other stuff. And maybe it'll be something maybe I'll get something interesting from the meeting I want to tell people about.
Yeah,
Yeah.
that'd be fun.
Am I tired from shoveling all of Portland's snow? Oh yeah. I mean, it was so much snow. It was really sad. It melted. Yes, TWIS, TWIS.org, our website, and there's a pop-up window and you use it and you sign up, and that'll make it the sign up and you'll be on our list. Yeah. You have a Peppa Pig calendar, Pam. That's not the same as our TWIS calendar with the science.
Mm-mm.
The science. I understand the thrall of Peppa the Pig, though. Actually, I don't. She's not one of the ones Kai was ever into.
Is that the one that's like made out of felt?
No, I don't know. Peppa's a pig.
Yeah,
Pig.
she looks like she's made out of felt to me. I realize she's probably not. She's just very two-dimensional.
Yes. Kids like two-dimensional things. Yeah. Everybody.
Oh, you don't see the newsletter when running an ad block program.
Well, there you go. Well, if you want to get on the newsletter and it doesn't pop up when you're running an ad block program, then you can email me and tell me that you want to be added to the newsletter list. And I will use your email and I will add you.
I think you can add like a what's it called? Like a discussion or whatever.
Oh my gosh, Identity 4, that's right. Identity, you were in Seattle. Seattle totally got snowpocalypsed. Snowed in. Is it melting now? Are you getting your bananas back?
Announcements. So I think you can make an announcement that is like, sign up for the newsletter.
You mean like if I put a post on our website?
Mm-hmm.
Okay, yeah, I could just add an announcement post. Okay. I need to have a better list of things that I need to get done. It's getting to the things that I need to do now are getting to the point where I think I need to write them down. Yeah. Yes, I can make an announcement.
Oh yeah, because I just went and I like signed myself up for the newsletter, and I was gonna put another email address in, but it won't pop up again after the one time. It's done. One and done.
We can use MailChimp to spam people. That's not what we want to do, though. What do you mean?
That's not what we're trying to do.
Yeah, you can buy email lists for cheap and add them without authorization. Yeah,
Rude.
I don't really want to do that. I mean, yeah. So our newsletter. We're gonna have a newsletter. We're gonna be able to sign up for a newsletter. Yeah, spam them with smarts. If only that would work. That would be great. Yeah. So I was thinking at first, I'm like, oh, we've got all these people supporting us on Patreon, and I have their email addresses, and then I was like, but they didn't sign up for a newsletter. They're supporting us and they listen to the podcast, but maybe they don't want a newsletter. And so instead of just taking the emails, I sent a message to a bunch of people, and I've had about a quarter of yeah, I probably had about a quarter of the people that I sent the email to respond, and the 99% of those were in positive. So probably could just take everybody and add them, but I'm not going to do that. I will not do that because I respect you people.
But on the other hand, if you're getting an unwanted email on a regular basis, how hard is it to spam filter it? Like,
Also, there's an unsubscribe button at the bottom.
okay, yeah, like I mean, I guess the
I don't want
presumption
to
of
opt
opting
out.
somebody in who doesn't want to be opted in sounds bad, but haven't they opted into the show? If you're talking about the Patreon group, like,
But they haven't opted into a newsletter. They want to support us and they like the podcast, but they don't necessarily need more things in their inbox. And
okay.
I'm not about to assume that
But
just
isn't
because
okay, but isn't sending an email asking if they want to subscribe?
that's
I mean-
just an email.
But I know.
I know. You're I know.
It feels like there's a point where it's like, we should just done the thing in the first place, except now we've done the thing where we asked to do the thing, but it's doing the thing. I don't know. These are tough
But
questions.
it was in the thing that they had signed into in the first place.
Right. That's what I'm saying.
Which is the system, Patreon system, allowing us to communicate with these people.
Okay.
But yeah. Not everybody wants to support us on Patreon. Not everybody, it's like the combo of things. I want to get all the people. Oh, Pam, you're giving me your email. You want me to put you in there? Go find it. Look at me. I'm gonna. Oh, I wonder if I can just add you.
Matachero, good to see you in the chat room. And yes, we should play chess again someday.
Did you play chess?
We did, and
That's
I don't recall exactly how that went. I assume that I won a bunch, but I think several times I always won. I think you must have beaten me at least once. Come on. Okay. All right. Almost once. It was so close. I haven't played chess in a long time, so it would actually be your best opportunity to take me down for sure. It's one of those things that it's not like a thing I'll brag about it now, but it's one of these things like I learned to play chess when I was like 6 or 7 years old. And so something about learning a thing that young kind of embeds it. Like I feel like even though I haven't played chess in years, I could hold my own immediately. It would just be like, oh, I'm gonna run for the first time in a long time, or try that yoga pose I haven't had. There's like a muscle memory to it. But yeah, that's something I need to do again. I haven't done that in way too long. And yeah, panoramic. Yeah, we should play again too.
I'm reading comments. Pam gave me her email. I added her. I learned something. I can add people. Ta-da. Ta-da. It's very exciting. Okay, newsletter. Live Portland show. I had a conversation today. It's potentially starting to come together. The location is still the theater location is still the tricky point. We're hoping we can get into this cool theater, the Alberta Rose Theater. I'm gonna work on the Wi-Fi situation there over the next week.
Isn't there a pub like crawly distance from your place?
Oh, it's not going to be big enough.
It's not big enough. Okay.
No, it's not big enough. Must be bigger. I'm gonna try. We'll see what we can do.
But if not,
Yeah,
there's
so
a
that's coming
benefit to a
around
pub.
April 3rd. Those of you who are in the Portland, Oregon area, put it on your calendar. April 3rd, if you want to come. Location TBD, TBA, but April 3rd, live Portland on a stage show. And I'm talking with, remember Jessica Hebert? We've interviewed her. She works on placentas.
Oh, yeah.
It was fantastic.
She's also in a small a trio called PDX Broadsides, who
Oh, yeah.
performs like geek core kind of music and pirate songs and stuff. They may perform during our break
Oh, that would be fun.
for our
That'd be
live
awesome.
show. Yeah, to have a little bit of live music for 10 or 15 minutes in the middle of our show, and then on we go. Yes. Yeah, so that is coming together. Wow, it's all coming together. And apparently, Blair, they open up the Science on Tap with trivia. So
Something I'm
be
familiar
ready.
with. Yeah.
Yeah, be ready. Be ready to play your trivia hand.
Well, I was always a host. I never really played, but I mean, I guess I could figure it out.
Figure something.
If it's animal trivia, I'll be set.
I'm really bad at trivia. I found I'm very confident about the answers when I'm wrong. And I'm always very hesitant about all my right answers. Like
That's always the problem.
Because the right answer pops up right away and it's like, it's this, but I'm always wrong when I'm that confident. But then, like, when I struggle to find it, I'm like, oh, I had to work to find this, therefore this must be true. Something weird. Trivia. Oh, trivia. If there's a Neanderthal question section, though, I'll be all ready. There we go.
I think you'll probably have that one. Neanderthal question?
Man.
You mean Neanderthal question?
Yeah. Is it Denisovan or Denisovan?
It is definitely Denisovan.
Denisovan.
That is
how
one is pronounced.
So yeah, I just remember the shift. It was sometime during, the last, it was around 10 years ago on TWIS, I think. It shifted from Neanderthal to Neanderthal.
Yeah.
And it just was this sudden shift that everybody in media decided they were going to do it. Everybody who was pronouncing it decided, oh, this is how we pronounce it now. And I was like, well, when did the memo go out? And why? And what's happening? And it took me a really long time to realize that it wasn't any big thing. It was just people saying, well, the Neanderthals were discovered and named in Germany. And since German, it doesn't have a th sound, it is proper to call it Neanderthal. And I was like, what? Can somebody just explain this to people before you just go changing it? I'm like, fine, but oh my gosh, it was like this simple thing. And it's like, well, and you can't find it anywhere. It wasn't on the internet. I looked everywhere on the internet, but I mean, the internet was old back then, so it probably just didn't have it. The internet wasn't as full of information yet.
But thankfully,
the Denisovan thing happened kind of suddenly too.
But that the pronunciation, I think that was like we discovered Denisovans, and then very rapidly after it was, you guys, this is how it's pronounced.
Yeah.
So part of it came about having read first. Denisovan is the natural flow of the word that you're seeing. But then when you hear the people who did the discovery saying Denisovan and knowing that it was named after a real something, then it's like, oh, well, okay, now I will adjust.
Yeah, but I remember somebody came up to us once and said, "You're pronouncing that wrong," and we were like, "No, we're not. No, sorry."
Yeah. Well, but to their, to their whatever, like, it wasn't just like that we had been pronouncing it Denisovan.
Yeah.
Popular media was doing.
Yeah, they were
not
saying
that
Denisovan.
we're not popular. I don't think we're not popular, Like it was, yeah. It took a
So
while.
I remember it. I mean, that was a couple years ago now, but I remember us talking about it, and I had just seen a lecture at the Cal Academy, and so the guy lecturing had done his life's work studying hominids, and was talking about Denisovan, and I was like, oh wow, okay, well if he's saying it that way,
Probably
that's
right.
definitely how you're supposed to say it.
Yeah.
Oh my gosh,
but
there's so many babies in our chat room right now.
But to be fair, like also, if you say Neanderthal versus Neanderthal,
it's not wrong.
Nobody's getting confused about what you're talking about.
Nope.
Denisovan, we all get it. It's cool, thankfully man. There's not a lot of other things that have similar names that then mean something else.
There's no Denisovan going, excuse me, you're saying my name wrong.
By the way, it's also not, we never called ourselves Denisovans. We have this whole other word, which you can't pronounce because your lung structure is different. I mean, where it's all, everything's placeholders anyway.
What was it? I saw something today that made me laugh. It was in Spanish, anana. In French, anana. In whatever, like anana. In this, like anana. Anana. In English, pineapple.
Pineapple. Mm-hmm. Mm-hmm. Yeah.
It's like every language. It's called anana.
Yeah.
Except English.
Yeah. Yep.
Like maybe we should just call it anana too.
That would be great.
And then it would be too close to banana.
Yeah. It's already taken.
I know, but we did the wrong one. That's the problem. We were too quick to name the banana. It's like the whole joke about the orange. Hey, what should we call these round orange things? Oh, call them oranges. How about these long pointy orange things? Crap.
Banana. They don't look like pineapples.
Well, wait. Which was introduced to this language first? I feel like pineapple showed up much later.
Yeah. I don't know. I mean, they're both tropical. So, in terms of like Europe, they didn't have bananas or pineapples in Europe.
Yeah. So maybe it was a misnomer. Do you hear about this banana? Yeah, it's a long thing with a peel. No. It's got stickly things kind of on it, and you have to cut it open, and it's really sweet inside. Like maybe they just were confused. So yeah, I want to know what those languages call bananas.
Right? What is
correct? Agreed.
In French, I forget what banana is in French.
Oh, man, I should know what that is.
I know, right?
So much for my French minor. Jeez.
Yes, Daniel Foland. I
was gonna
YouTube.
say it, and I was like, "That's stupid." It's the whole Justin thing again. It's banan.
Banan, un banan. There we go, banan.
Oui, banan.
Yeah. Daniel
It'd be
Foland.
funnier if it was pineapple.
I may use the newsletter to urge Patreon signups. It may happen. Yes. Pineapple. What is going on? Is that a cat or a human? All sorts of noises happening above me. I don't know what's happening. Bleak, you think I should add a subscribe link to the page? Okay. Yeah. You click the subscribe window away once and it never comes back. I could make a link. I could do that also.
I'm trying to log into MailChimp and it's asking for...
I'll get rid of the calendar link and put in a newsletter subscribe link. Yeah, good. Pineapple. Piña. Yeah, you don't want to... What do you want to ask for? A anana colada? Subscribe link on the subscribe page. Thank you, Matajuro. Thank you. That's a great idea.
Okay. Silly MailChimp.
I'll do that. Oh,
So,
virtualmicroscope.org. That's a great site.
Let's see.
I like virtual.
Oh. Lists. That's what I want. Lists. Ooh, 79 subscribers.
Cool.
Me too.
Yeah, I'm watching the names.
Oh yeah, sign up form. That's what we want.
Mm-hmm.
Yeah, we just want a form because then we just have
Embedded.
an
Yeah.
I guess we want an embedded form.
Mm-hmm. Classic. That's too big. Condensed. There you go. Subscribe to our email list. Here it is. Email address. Subscribe. Ta-da!
Great. You can
That'll-
plop that right in the
Uh-huh.
chat room. Is it, or do you need to put it on the site somewhere?
No, I have to put it on that.
Yeah.
Onto the site. I will have to put it. Copy and paste somewhere. To the top, what? To the head of my HTML. Which HTML file? I'll figure it out. Figure out where I want to put it. Put it
Yeah.
somewhere.
I think, I mean, an announcement would be fine. I feel like a tab would be like best case, but that's way harder to make. So, like right next to Patreon, like newsletter. But I feel like that's way harder to do.
Uh-huh.
So, I don't know.
No, I'll find a place to put it. Figure out where to put this little embedded form, and it'll just be stuck there.
Yeah. I mean,
I have
it
a
could just
feeling-
be right under subscribe to TWIS, I guess. It could be a little box.
Mm-hmm.
Nice.
Yeah, we'll figure that. I'll figure that out. And where's Justin going?
I'm
You falling asleep?
fading.
Yeah, I need to go also. It's 10:30. I need to finish packing for Washington, D.C.
Yeah.
Hmm. Yeah, I gotta finish my packing. I think I have everything mostly packed. I just need to pack my backpack and make sure I have. Oh, but I have to make sure I can't pack my computer until I download the audio files, and because I have to edit the show on the plane tomorrow. So I have to remember to pack my headphones. It'll be fun. I'm going to do all the working on the plane tomorrow. I'm going to be one of those people. However, I would prefer to just sit and veg out to watch a movie, but that'll be maybe on my way home on Sunday. Relax on my way home. Yes. Davis to Bakersfield. That's fun. Why did you? Oh yeah, what was your adventure?
It was auto booth, right?
Oh, you went the bus.
Got a school bus.
You got your school bus.
Yeah, I got it.
Okay, cool.
And it drove all the way back.
Drove beautifully. Well, like I was saying, it's like riding on earthquakes. Everything shakes. It was like I was in a massage chair for like 6.5, 7 hours or so.
That's I mean, even larger cargo vans are like that. Their suspensions are just very unforgiving.
But the I bought the thing for the shell and hope to make it 50-50 chance of making it all the way back, assuming I was probably going to have to leave it at a shop at some point to figure out what was wrong with it. Nothing. Things in beautiful shape.
Wow.
Drove great and is rust free.
What?
Yeah. Well, this wasn't down. Cool. This thing lived in Bakersfield, even though it's
It's dry
Oh,
down there.
Gosh, where is it? It's really kind of an old. It's 25-year-old school bus. But yeah, Bakersfield is dry, arid land. I looked all under it. I haven't found a significant rust patch yet. It rained heavily on it today. Didn't leak. And yeah, like I said, I bought it for the show, but the guts are great. She's got heart.
Great.
So yeah, I'm very excited. So for the next 8 to 12-ish months, depending on how long this whole thing takes, it's gonna slowly be getting converted into an RV.
Yeah. That's cool. That's a fun project.
Yeah.
So much fun. Metajuro wants to know if you're gonna make it electric.
No. But if this was 20 years in the future and we were having this conversation, I might only be able to be looking at retired electric school buses. They are showing up for reals nowadays. There are natural gas compressed natural gas school buses that become available, but no, the electric school buses that are now being made are going to be, the 25-year from now generation of Justin buying a used school bus are going to be able to pull that one off.
Yeah, it's funny, the CNG thing, everyone was sure it was going to be the next big thing for these kind of heavy tow weight vehicles when I was looking at acquiring a cargo van, and actually I've done that a few times in the past 10 years, and every time it's like the new best next thing. So in 2005 we got a Zoomobile that was biodiesel, and that it sat for a month during the summer when it wasn't running, and the biodiesel ate through the fuel line. And since then, everyone's like, oh yeah, biodiesel, what a hack. Like, not any cleaner, not cheaper, not better. And then CNG was like the thing that everyone was talking about when I was looking at buying a cargo van for the aquarium. And it was the thing. Like, everybody's fleet websites, Ford, Chevy, like all of them said like CNG vehicles now available. So excited. Can't find them like anywhere anymore. And now they're just pushing on the like, hey, we have really good gas mileage in these vehicles for a cargo van. Like, hey, we get like 25 miles a gallon. That's really good for a cargo van.
So yeah, and there has been a lot of improvements in the combustion engine thing. There's
absolutely,
there's cars out there that are getting better gas mileage with a standard, what is now the standard compression or gas engine than my hybrid, which is now pretty old. But so yeah, like technology is improving all the way around on these things.
Yeah, I think I'm really excited to see what happens with electric fleet vehicles, because it seems like they keep talking like it's going to happen, or it's plausible, or even hybrids are plausible. But then when you get down to it, somebody says like, oh, well, I'll aftermarket take your cargo van, and for 30 grand, I'll transfer it to a hybrid, but then you can't have the same tow capacity as you had before. So it's like, it's a whole separate thing still, but I'm seeing, these twinklings, I'm still waiting to see a Tesla big rig. I haven't seen it. Like, it was on that stage, but I haven't seen it out on the road yet. I'm really hoping that it happens.
But if you go look at transit bus and school bus manufacturer websites right now, they're all pushing their electric buses.
That's great. Yeah, I hope it works.
Yep.
I'm excited. It seems like people are kind of getting behind it. Finally. And I think, to their credit, I think there is something to the Tesla movement that has made it kind of like sexy and attractive and interesting for people to put their money behind in a way.
But also natural gas played a very pivotal role in this because cleaning up the air in these cities that are looking for these clean buses pushed the interest in coming up with something that might be more efficient or more practical than the natural gas vehicles, with an easier to add infrastructure. And there's this strange maintenance things that you have to do of draining natural gas tanks and pressurizing, and there's a lot of difficulties in really maintaining a fleet like that that they eliminate by pushing the envelope further and developing these electric vehicles. So the CNG vehicles played an incredibly important role, I think.
Yeah,
in this transition.
You're right about that. Yeah, well, because they were pretty much trying to do everything but, and eventually went like, I guess we got to do the electric.
Yeah. And the technology has improved too. So
absolutely.
all these things have to happen.
Yeah, I mean, that's the whole deal with solar panels too, right? I mean, in San Francisco and in Daly City, like if you wanted to have solar panels out here, good luck to get, to be able to turn a light on 10 years ago. And now you can collect enough solar power through clouds on a foggy day to power your whole house. It's really phenomenal, the turnover that's happened, and it's unfortunately but fortunately because of the early adopters, right? I mean, they paid more for less so that we could have better technology. It's a weird way this whole thing works. I mean, if government subsidized the technology development a little bit more, maybe it wouldn't happen. But with the situation that we have to thank those early adopters, right?
I know
those people that bought the Model S. They're the ones who allow us to have the Model 3 that's $35,000, right?
I now want to see an entire episode of TWIS where it's Blair corner of her mouth.
Blair trying to talk about politics without being too polarizing. That's what that side mouth is about.
And speaking of which, I also now can power all of my electronics over with solar panels that could fit on the roof of, say, a small school bus.
There you go. I was going to ask you about that. I hope you're going to do that. That's awesome.
Absolutely.
I love that.
Yeah, Matajuro suggested Fully Charged, a YouTube channel. It's pretty awesome, and I recommend it as well. It's a very good channel.
Oh, nice.
They do awesome things. Yeah. Bedtime?
Yes.
Okay,
Yes.
we will leave you. Here is it on Twitter. The hashtag academic Valentine is a big one.
Oh.
Roses are red. In French, they are rouge. May your Eppendorf lids not break off in the centrifuge. I made up one that I haven't written yet. It's science is smooth. Wine is smoother. Put them both in the lab and you get a twofer. Happy Valentine's Day.
Oh my goodness.
Poetry by Dr. Kiki.
Yay.
All right. I think on that note, say goodnight, Blair.
Good night, Blair. Say good night, Justin.
Good night, Justin.
Good night,
Kiki.
Good night, everyone. And we will see you next Wednesday, 8 p.m. Pacific time. Don't forget to come see us again for This Week in Science. We'll have an interview next week. It'll be awesome. And that is all. If I can find the off button. There's a button here. There it is. Stop broadcast. Have a wonderful sciencey week, everyone. Happy Valentine's Day.